Assalamualaikum, brothers and sisters.
Waalaikumsalam.
Let's start our day with the recitation of Kitab Al-Fatihah. A'udzubillahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin, arrahmanir rahim, maliki yaumiddin. Iyyaka na'budu wa iyyaka nasta'in. Ihdinas siratal mustaqim. Siratal ladzina an'amta 'alaihim ghairil maghdubi 'alaihim waladdallin. Amin. Okay, as usual, we start our day with a recitation of dua. This time by Ustaz Amirul. I saw him online just now. So Ustaz Amirul, tafadhal Ustaz.
Bismillahirrahmanirrahim. Allahumma nawwir bil kitabi absarana wa shrah bihi sudurana wa sahih bihi abdanana wa adliq bihi alsinatina wa qawwi bihi jinanina. وأسرع به فهمنا وقوي به عزائمنا بحولك وقوتك فإنه لا حول ولا قوة إلا بك يا أرحم الراحمين اللهم استودعناك ما علمتناه فارده إلينا عند حاجتنا إليه ولا تنسناه يا رب العالمين.
Amin ya rabbal alamin. Shukran Ustaz. All right. What are we going to do today? Okay, we have done in the previous class, if you can recall, we did focus on simple moving average. Remember that word? Simple moving average. Then what else? Weighted moving average. Can you hear?
Yes.
Okay. Weighted moving average. Then any more? Exponential smoothing. Exponential smoothing. And we did a seasonal forecast. As I said in the last class, we tried to use the last few minutes. I show you the simpler one to solve, seasonal. But that's not in the syllabus. The one I'm going to do today, the thing we are going to do today is in the syllabus. So we have this seasonal forecast also. But this time we have 4 steps. You can try to remember this. Calculate the seasonal index. Step number 1. After that, deseasonalize the data. And then after deseasonalizing it, we work out the trend, the straight line for the deseasonalized data, and then make trend projection. After that, make a trend forecast. Once done, we reverse it again. Finally, this forecast figure have to be adjusted or reversed into seasonal forecast. Okay, let's see how we do. Conceptually, I just illustrate the conceptual. Let's say we have some quarterly informations, maybe sales, or let's assume sales, quarterly sales. Let's say in year 1, we have quarter 1, quarter 2, quarter 3, quarter 4. Quarter 1, we have low sales. Quarter 2, high. Quarter 3, it's a little bit lower. Quarter 4, much lower. And then the following year, similar pattern occur. Similar pattern, you notice? Similar pattern, but now the first quarter of the subsequent year is a little bit higher than the previous one. That means the company doing better, doing well. The same thing on the second quarter, the sales also very high, similar to the previous year, but this time much better than the previous year, but the pattern remain. And then third quarter, the sales move down a little bit, and then come to fourth quarter, it go down. And similarly on year number 3, and it goes on similar one. So how are you going to make forecast for the subsequent year, quarterly forecast? Are you going to take any one of this, copy and paste somewhere here? You can copy and paste. You can copy and paste. Why not try? So what we are going to do, we are going to say what we do. Calculate the seasonal index. We are going to compute seasonal index and then use that index. This is seasonal data. We are going to make this one into not season, unseasoned. We try to use the seasonal index to deseasonalize, to make it not seasonal. So what we do, deseasonalize the data into trend. And this is conceptually, we are making it into a nice pattern like this, similar to trend. Then develop the trend line or trend equations, and then make a trend forecast. Develop the trend line, then make a trend forecast. So trend, we have T1, so the quarter 1, quarter 2, quarter 3 become 1, 2, 3, 4, quarter 1 for year 2, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 data. And then, you see, develop the trend equation. We are going to find the trend line, I mean the equation of this trend, and then make a trend forecast for the subsequent year. Say our job is to make a forecast for year 4, make quarterly forecast for year 4. Quarterly forecast for year 4. So what we do, we make these trend projections, and then we make trend forecast, make trend forecast for week for T equals 13, 14, 15, 16, and this may illustrate the trend forecast. But what we are asked to do is to make quarterly forecast. Then use back the seasonal index. Then we reverse this into seasonal. So seasonalize the forecast data. So make it into seasonal again. So you follow the pattern of the previous years. So this is a little bit exciting. Okay, let's try this example. The example here, the sales of tennis racket in thousands. Year 1, year 2, year 3. We have quarter 1, quarter 2, quarter 3, quarter 4 sales. Say quarter 1, 3,000. Quarter 2 on year 1, quarter 2, 9,000. Quarter 3, 6,000. Quarter 4, 2,000 for year 1. Year 2, quarter 1, 4, 11. Quarter 2, 11. Then 3, 8. Quarter 4, 3. Similarly on year 4. So what are we going to do? Step number 1, we are going to compute what we call, seasonal index. We are going to compute, we are going to calculate the seasonal index. How to do that? We rearrange the format of the presentations of the table. Now you put it vertically, year 1, year 2, year 3. Then we have quarter 1, quarter 2, quarter 3, quarter 4 for each year. And on the right hand side here is the quarterly sales. Quarterly sales written on the right hand side. Now we are going to calculate the seasonal index. So what we do, we have to do up this table. This is the quarter, the year, and then we do alternate spacing like this. alternate space, Q1 space, Q2 space, Q3 space, 4 space, and everyone space except the last one. After that, no more space. Then we write the quarterly sales over here. This is the quarterly sales on the third column. And then we calculate what we call the 4-quarter moving average. Moving. When moving, we are some use the word rolling average. So what we do, take 4 quarters, 1, 2, 3, 4. If you have, say, monthly, you have 12. Then you have to have a set of 12 like this. Or bi-monthly, you have 2. 2 months once. That means in 1 year we have 6. So you need 6 set of this. So in here, Q1, Q2, Q3, Q4. So we take 4-quarter moving average. So what we do, we take the average of these 4 right at the center. Take the average of these 4. How to take average? 3 plus 9 plus 6 plus 2 divide by 4, and you write at the center here, somewhere in between this space. Get it right? You want to verify these calculations? 3 plus 9, 12, 12 plus
Yes, correct.
18.
Divide by 4.
Yeah, correct. We do the same. We do the same for the subsequent one, the next 4. And then right at the center. For my calculation, I round it off to 2 decimal place. And then we do this next one, the same one, every 4, every 4, every 4, until you cannot do anymore. The last one, the 4, the center is somewhere here. So done with this, we have 5, you do the same, 5, 5.25, 5.75, 6.25, 6.5, 6.75, 7.75, 8.5, 8.5. Then what are we going to do with this? So we are going to take what the next one is, centered moving average. Centered moving average, CMA I put up there. Centered moving average. So this column is referred as centered moving average. We take 2 only, 2 of this, and then take the average of these 2. Take the average of these 2, write it here. You have 5.125. I write it here. 5 plus 5.25 is 10.25 divided by 2, 5.125. So write it here. And then the same thing for this one. Take every 2, write it here. And then take every 2, right here, and until you cannot do anymore. This is the last 2. Now you have how many sets of number? 1, 2, 3, 4, 5, 6, 7, 8. Then the next step, the last column, is actually calculating the seasonal index for each quarter. The seasonal index for each quarter. How to do that? You take this number, the actual sales, or we call it YT, seasonal YT or seasonal data, that correspond to this centered moving average. You see this one, this one. On the row, it corresponds to this number 6. So this number 6, divide by centered moving average, you get this seasonal index for quarter number 3, 1.17. So this is the way, seasonal index, actual sales data, divided by the centered moving average, you get this number. And then we do each and every one. This number divided by this number, you have this number. 4 divided by 6, you get 0.67. 11 divided by 6.38, you get this number. So these are the set of seasonal index. Okay. This 1.17 is the seasonal index for which quarter? Can anybody say something? Quarter 1, quarter 2, quarter 3?
Quarter 1.
Quarter 1. Yes. And many students, since it is the first one, you say quarter 1. Look carefully.
It's quarter 2, doctor.
3.
Huh?
Quarter 3.
Quarter 2 or quarter 3?
Quarter 3.
Quarter 3. So this 1.17 is actually the seasonal index for quarter 3. The same one here, 0.36, quarter 4. 0.67 is quarter 1. 1.72 for quarter 2. And it go on. So quarter 1, this one for quarter 1, it corresponds to quarter 1. Quarter 2, this one corresponds to quarter 2. Quarter 3. Just now somebody, brother say this one is quarter 1. That's where most students make mistake in exam. They use this as quarter 1 index. Now I illustrate, I emphasize, look carefully. It corresponds to which one? So this 0.67 corresponds to quarter 1. So this is the index for quarter 1, quarter 2, quarter 3, and quarter 4. And then we have another set. Also quarter 1, 0.62, quarter 1, quarter 2, 1.76 for quarter 2, quarter 3, quarter 4. You notice the pattern? Quarter 1, the index is close together, right? About 0.6. Quarter 2, about 1.7 here. Quarter 2, 1.7.
So it's
1.7.
0.04 difference.
Yeah, yeah. I mean, what I want to illustrate is the closeness. The closeness. Here, quarter 3, 1.17. Here, 1.2. Here, 0.6, 0.6, 0.3. Here, 0.4. 0.36, 0.4. Very close. In this case, we had two sets of index. So what we do, we try to average out this index. Okay, this is how we do. This is the first set. Quarter 1, quarter 2, quarter 3 indexes for the first set, the second set, and then we take the average of the two, and then we add it up, get 3.97. But the best is when you add it up, it should equal to 4. As if this one, 1, 1, each quarter represent 1, 1, 1, 1, quarter 4. So if the number here is quite different from 4, it's best to you regularize so that it add up to 4. If so little, like 3.9798, I mean, not much different. But for illustration purpose, I just show you. This is how I think you know how to regularize this. So we make the index so that the total for here 0.65, 0.66, because this number 3.97 is very close to 4. But if this is 3.85, then it makes a lot of difference. So this is the index that we are going to use later on. We are going to use this index. What are we going to use for? Okay, before that, what does this index represent? So what it says here, if there is if I put a bar here across 1, here I put something like 0, 1 to 2. if 1 is the normal sale, if 100 is normal sales, it means that Q2 you have 75% more than normal. So Q3 we have about 20% more than normal. That means above normal. Here, very much above normal. Q1, 0.6 somewhere here. That means how many percent below normal? 1 minus 0.6, about 335, right? That means 0.335 below normal. Q4, somewhere here, about 0.4. So that means about 0.6 below normal. So this is what the index represents. Now the next step, what was the next step? Deseasonalize the seasonal data. Deseasonalize the seasonal data using the index. This is the quarterly sales. This is the seasonal data. This is the index for each quarter. Q1, Q2, Q3, Q4. It repeat Q1, 2, 3, 4, 1, 2, 3, 4. Okay. Take note this sale, the first one, this is seasonal data. This one, seasonal. So we are going to make this into trend. We are going to make it into trend YT here. We are making this into trend YT. This is this one seasonal. We are going to make it into trend. Say the next thing, deseasonalize. That means we are making it into trend by dividing the seasonal seasonal data by the index. Then you get this number. And you do for everyone. You do for everyone. You see the pattern now, at least move a little bit up and down. And this one become like trend data. Oh, we did trend last class. We did trend. Then let's say this one, the first one, T1, T2, T3, T4, T5, T6, T7, T8, T equals 9 and 10. And then we are going to find the trend. We are going to find the trend. See, 12, we are going to make forecast for year 4. We are going to make forecast for year 4. Year 4, Q1 represent, Q1 will be T equals to 13, T14, T15, T16 for year 4. So you remember to make the trend. We don't show you the detail. Remember, we have to find sum of T, sum of Y, T, sum of T, Y, T, sum of T squared. So we are going to take this number again. So this is the YT we are going to find out, sum of YT, sum of T. We need to use this one, and then sum of T times YT, sum of T squared, and this one, and illustrated here. So what you're interested at the last number, I think so this is actually sum of T, this 78, the last number. The next one is sum of, what is that? What is that, 79? Sum of YT here, 572 is sum of T times YT. And the last one is sum of T squared. And you remember we are going to find B0, B1 first, then B0 to get the equation of T equals B0 plus B1T. This is what they say. We are going to find the trend. We are going to find this thing. So using these informations, you substitute in the formula, which I'm not going to show again. So this is what we get. Yeah, we get B0, B0. This is B0. This is B1. And then substitute T equals 13. T equals 13. T equals to 14. T equals to 15. T equals to 16. And this is what you get. What do you get now? This is still a trend forecast for year 4. Is this still trend forecast? So this is still trend. Step number 3, you see, find the trend. We already find the trend and make a trend forecast. So this is the trend forecast for T13. See, the pattern is like a trend, 9.1, 9.5, 9.9, 10.5. What's the last one? The last step? Seasonalize it
Adjust.
again. Again, adjust.
Adjust with the seasonal index.
Okay, adjust. That means in the simple term, we are making this into seasonal again. We are going to reverse into seasonal. How to do it? So this is how we do. Use back this is the trend forecast we showed just now. This is the T for year number 4, quarter 1, quarter 2, quarter 3, quarter 4, T to 13, 14, 15, 16. This is the trend forecast. The trend forecast and trend forecast. So use back the set of seasonal index that we calculated just now. This time, instead of dividing, we multiply. So 9.1 or 9,000 times 0.655, you get this number. 9.5, you get this times 1.7, you get this number. Same thing for quarter 3, quarter 4. I repeat. So now we are making quarterly forecast for quarter 1, year 4. You get 6,000. Quarter 2, year 2. Sorry, quarter 2, year 4, 16,000. Quarter 3, year 4, 11. Quarter 4, year 4. So this is your quarterly forecast. And this is actually the answer. Let's compare with the previous one. This is what we have done. You see the pattern, 3, 4, 5, 6, almost the same. The second quarter become very high, 6 jump to 16, 9, 11, 15, 16. You follow the pattern for each quarter. Here 6, 8, 11, here almost 12, 2, 3, 3, 4. So this is the quarterly forecast. Okay, what do we have to do? Calculate the seasonal index, step number 1. Use this after you get the seasonal index, step number 2, find the trend. Sorry, using the seasonal index, we deseasonalize the seasonal data. Then step number 3, find the trend and then make trend forecast. Then the last one, using the index, seasonalize again the trend forecast, and you will get the seasonal forecast. Okay, between the one that we showed last class, which one do you prefer?
This one is more complicated.
This one more exciting, right? But sometimes the exam you are asked to do this method, brother. All right, done with seasonal. Let's accompany sister to do shopping. Brother Haziq, you want to accompany sister to do shopping?
No.
No. Okay, sister, if you are going to do shop, what are the things you are looking for? Say you are looking for your dress for your birthday party. You look at nice, this a glittering dress with labuchi here and there. Design?
No, firstly a cake.
Huh? Can I say design first?
Maybe a cake first.
The? What first?
Cake, birthday cake.
How to spell? No, the cake. They say you want to have to buy a dress. Let me put design. Agree?
Okay, sir, you may.
Okay, for the purpose of discussion, say design. Design. You see the design so nice with labushi, all this thing. Then you ask the shopkeeper, they say 10,000. Will you buy, sister? Unless somebody pay for, then you take it. If not, say you have to pay from your pocket, are you going to buy?
No.
No, doctor.
No money.
Not enough. Not saying that no money, not enough. So what are the next thing you have to consider? Price. Let's say a price. If the price is right, the design is right, are you going to buy?
No.
No, the size may not right.
Yes.
Okay, let's look into size. Then, any more? Say quality. I think enough for discussion purpose. Quality. Okay. If the design is right, say maybe not exactly what sister want. The price, maybe she is expecting about 500 ringgit. Then about 550, okay lah. You say, okay, can. The size, she is looking for size S, available. The quality, a little bit, okay, not so okay, but I like it. Would she buy?
No.
Will you buy? I said, this design is almost right. Price is right. Size is right. Quality is right. You don't buy.
Yes.
Yes.
We buy.
Yes, you buy. So let's look into sister's purchase decision. Purchase decision. So your decision is dependent on design, your price, the size, quality. Correct? Your decision, if design is right, price right, size right, brother can tell tell me that sister will buy. Agree?
Yes.
Agree.
Yes, agree. But if design is right, price is not right, but the available size is the big size, quality is right, you think sister will purchase?
No.
No, no, no. So let's put this into equations. Y, your purchase decisions equals to, let's say design is X1, price X2, size X3, quality X4. Okay, so are you familiar? Have you seen some equations, something like this before? In somewhere in your maths or statistics class? Plus error. Or maybe you have seen something like this, W0 plus W1 X1 plus W2 X2 plus W3 X3 dot error. Are you familiar with this equation? Hello, are you
Yes.
there? Yes. Yes. What equation is this?
Simple linear.
Simple
Linear.
linear regression. Someone say linear regression. So we are having linear regression. So what are this design, price, size, quality? What do you call this variable? Purchase decision is what? Independent variable? Dependent? When your purchase is dependent on design, agree? Price, size, quality, agree?
Yes.
So we call it this dependent variable.
Dependent variable.
Dependent. Oh, my spelling is right. Dependent variable. This one, all this?
Independent.
Independent. Independent. Or sometimes we call it predictor variable. Because if I know this one fit sister's taste, the price fit sister's purse, the size fit her body size, the quality is just what she like, I can conclude she will purchase, right? But if this is not right, one of them not right, then we can conclude that she will not purchase. So when you are doing purchase, I think you are balancing between these different variables. That means you are actually having some weight here. You are having certain weight here that you are balancing. Maybe here not exactly 100%, say design not exactly what you want, but almost what you want, say 0.9. Maybe you don't have the number when you are at the shop. The price, okay, maybe about 0.95. Size, not really fitting, but okay, 0.85, let's say. Quality may not be what you want. Maybe you put some weightage about 0.8. I think this is okay. So while you are purchasing, you are actually balancing this one. This one okay, this one okay. If all obviously not okay, then you will not buy. If this is almost what you want, I think you will buy. So we have, now let's look at regression, linear regressions. What we have just now, we have multiple linear regressions. We have a lot of variable. If I were to rewrite something like this, y equals to b naught plus b1 x1. This one, I call it simple regression. I think you just revision a little bit on our mathematics. So regression, we are going to do regression method, or we call it causal method. Regression analysis is a statistical method to develop mathematical equations showing how two variables are related. Just now, remember, variable that is being predicted is called dependent variable or response variable. Variables being used to predict the value of the dependent variable are called independent or predictor variable. So for our case, we are using simple regressions, simple linear regressions, regression analysis involving only one independent variable and one dependent variable. Multiple regression involving two or more independent variable. Okay, so we are going to use this simple equation y b0 plus b1x. Y is dependent variable, and then I think you know this b0 b0 since it's linear equations. We have some y-intercept here, b0, the same like our trend. This is x. X is the independent variable. So the same thing, we are going to use the least square method like what we did in trend. Instead of tyt, we find b1 using xy minus sum of x over times sum of y over n divided by sum of x squared minus sum of x squared over n. Recall, if we trend is tyt, sum of t times yt, sum of yt, here sum of t squared, sum of t whole thing squared. It's exactly similar. But except now we use the variable instead of t, we use y. Instead of lowercase t, we use x. So here, this linear regression is applicable for effects, cause and effect. We call it causal method. Just like in the early part of last class, how would Brother Flair in how he will achieve if you study extra hours. 1 hour will increase by so much. As he would study 2 hours, he will increase his GPA by how much? He study 3 hours, his GPA increase by how much? I mean, the relationship, it will be the hours spent to study will affect the grade. So now let's look into another scenario. Maybe Brother Ashraf have a restaurant. Brother Ashraf, are you there?
Yes, doctor.
You have a pizza outlet at different university, different campus. You have 10 restaurants. Wow, brother, sister, see brother so rich, so many restaurants.
Maybe 20 years later.
20 years later. Okay, so he has 10 restaurants, and then the one of the restaurant, one of the pizza outlet, he put in a campus with 2,000 students. The second one, he has this one in an outlet with 6,000 students. The third one, 8,000 students. The fourth one is in the campus with 8,000 and so on. And the 10th outlet is in the campus with 26,000 students. And then from last record, brother have collected this information. That means each quarter sales, he get about 58,000 on first restaurant that has a 2,000 student. The second restaurant can generate about 105,000 quarterly sales on the outlet with 6,000 students. And similarly, for the rest, let's say the last one, it generate 202,000 when the restaurant is located in the campus with 26,000 students. Now, brother is trying to make another outlet, maybe in Pago, maybe over there 30,000 students. He wanted to predict the sales. If he were to open a pizza outlet in Pago, let's say, would you, brother? Yeah.
Inshallah.
Inshallah. Okay, how to do that? Now I want to know the student depend on sales or the sales depend on the student?
Sales depend on student.
Sales depends on student.
Sales depend on student. So which one is the dependent variable?
Sales
Dependent.
Sales is dependent. The student populations, this one?
independent.
Independent. Okay, let's predict brother's sales. He is going to have an outlet with 30,000 student population. Okay, we do the same. We are going to put in the equations. Now find sum of xy, sum of x. Just know these are the x is the number of the student populations. Y is the sales, xy. So we are interested at these equations: sum of x, sum of y, sum of xy, sum of x squared. So substitute this in your equations. You will, I don't show the detail. Substitute in the equation. This is your regression equations. Okay. I don't show the detail, but the method is the same. So now if brother were to open up another outlet, if 30,000 students, what do you think his sale would be? Can you predict brother's sale?
Yes.
Yes. What will be his quarterly sales? 30 times
210.
210. So 210,000 sales. So you get the idea? How
Yes.
about 16,000? If you are going to open another restaurant at another place with 16,000 population, can you
140.
140,000? Okay, you get the idea? So this is causal effect. That means one is dependent over the other. This is this restaurant number. You don't use this number. This one is only just listing. So you only use these two sets of a number x, y. And then you must be able to differentiate which one is the independent variable, which one is the dependent variable. Let's figure out, we have a class, physical class. At the beginning of the class, brother enter the class, and then sister enter, and one brother sit at one corner and sister sit at another corner. Next class, brother enter the class, sister sit by the side. The following class, brother enter, sister enter, sit on brother's lap. The last class, I do not know. What are these things? The first one, any relationship, brothers, sisters?
No.
No. Second one?
No.
No. Third one?
Yeah.
Yes.
Yes. What is this diagram? Remember in
Venn
statistics?
diagram.
Venn diagram.
Venn diagram. Let's say, okay, forget the brother sister. Let's say the green represents student population. The pink one represent pizza sale. The second one also represent. The third one represent same thing. Now, just now the student populations on the first one, if the student population is so much, would it increase the pizza sale on the first one? Yeah. Any relationship?
No.
No. The second one?
No.
No. The third one, if I were to, if the student somehow increase in that particular university, would it increase your pizza sale?
Yes.
Yes.
Yes. Yes. That means there is some relationship. So we want to know how strong this student population can affect your pizza sale. A situation like this, maybe if the relationship is very strong, one, let's say one, every 1,000 population increase, and there will be a straight correspondence with the increase in pizza sale. If there is an increase of say 100, in this case, if this is the relationship is weak, maybe maybe the population is very high, but the pizza sale increase slightly. So let's look into this relationship. What do you call this relationship?
Intersection.
Intersection. Relation. There are two relations here. The correlation, remember that word in statistics?
Yes. Yes.
Yes, correlation R. Okay, let's find how strong is the student population affect your pizza sale. Let's find the correlation. So we are going to find the correlation coefficient. Correlation coefficient measures the strength or the relation between the dependent variable and independent variable. And you know it is denoted by R. And it always range between 0 to 1. And this is the formula to calculate the correlations. Almost the same, xy, sum of xy, sum of x, sum of y, sum of x squared, sum of x whole thing squared. Now we have another variable that we have not computed before, sum of y squared. Sum of y we have here, and then whole thing squared. So we have new one here, only this one which we don't have yet. So the same way we substitute this one, what we need is sum of y squared. We have this sum of y, substitute all this number, sum of x, sum of y, sum of xy, sum of x squared, sum of y squared into this equation. You will get 0.95. What do you think about the relationship between the student population and your sale?
Very strong.
Very strong. That means you can use student population as the basis to predict your sale. That's what it means. What if R is 0.3?
Weak.
Very weak. That means it's not a very strong predictor about your quarterly sale. Are you with me? I hope you get the point.
Yes.
Yes. So we can conclude that there is a strong correlation between your pizza sales and student populations. So here the sales is heavily dependent on student population. Of course, there are other factors, maybe the design of your outlet, and then the promotion. Of course, we don't discuss. We are working on what I call it simple regression. Then you want to try multiple regression, you collect data on what will be the effect on promotion, what will be the effect on the design of your outlet, and then how about if you open to the people outside, and then the menu, your pricing. Then you can use Excel, that's the spreadsheet. You can work out you regress, then you can find the relationship. Then you can develop an equations. All right. Any questions so far? So far,
Doctor,
yeah.
is this correlation can somewhat be similar to the normal distribution, the bell-shaped one?
Normal no, that normal distribution you are saying about those standard deviations. Are you referring to that?
Yeah.
No, this is not standard deviations. If you use regressions, you can find just now y equals, say, b naught, b0 is the interception, the y-intercept, plus b1, let's say x1, you collect data just now, you see sets of data about the student populations, and I can put another one. What will happen if I were to do the other pricing? Then I get b2. So x2 is the pricing of your product, but you have to collect data, and then plus b3 x3. Then if you regress using the simpler, you have advanced calculator, you will get this value. You will get this value. Then this value will tell you that is whether there is any relationship, a strong relationship, or not at all. In this case, we have 0.95 x1 y. Sorry, no, this is not. So you regress, you get this one. You will get the weightage. Then you can also correlate this to, correlate this to. There is also a way, an intercorrelation between this and this also. Of course, that become more sophisticated. You do masters and you can do that. Or you can try out on your own. But it is not, this is not normal. You mean this one, brother?
Yeah.
Normal, no.
Distribution.
No. All right, done with this. So we are done with quantitative methods. Let's move on to qualitative methods. It's qualitative. What do you have to do qualitative methods? When you don't have data. You want to do something and then you cannot collect data, or data is not available. So we have a few methods here. Jury of executive opinion, or sales force composite, consumer market survey, Delphi method or Delphi technique, expert judgment, scenario writing, or just simply intuitive approach. Okay, what is it? Jury of executive opinion. Actually, it's just a small group of high-profile managers. That means those who are knowledgeable about the area. Then we put them together, pull their judgment, and collectively make the forecast. That means we call them for a meeting, and then everybody make their experience estimate. You say you want to make a forecast about your new product, then you call your senior people, and then what do you think will be the quarterly sale or the annual sales for this year? If I were to put this in the market, for example. Another one, sales force composite. This is a bottom-up approach where we collect data from salesperson on the ground. The salespeople the salespeople on the ground say these are a few salespeople, and these people will report to maybe one of the sales executive, and then there are a set of people in another side. And these people are on sales executive 2, sales executive 1, and then these people, and there are many others, and these people will report to sales manager, and then there are more than sales manager, more than one, and maybe up there sales director. So this report to sales director. So what happened is those on the ground make an estimate about the future sales, if we are working on sales, and then all these are collated upward, and then up to the top people, and then they make the estimate. So this is how we call it sales force composite. We call it bottom-up approach. Another way is consumer market survey. Survey potential customers about their future purchasing plans, especially when you are introducing a new product. I think you ever encounter at the shopping mall, people ask you some questions. If this is will be to be sold at your place, would you purchase or not? This is a simple what you call it a consumer market survey. But the challenge is developing the questionnaire. You have to develop a good questionnaire that can be useful to your organizations. Another one is Delphi technique. Imagine you have branches, just know like Brother Ashraf, they have an outlet of pizza, one in USM, one in UM, one in UKM, one in. So what he do is he get some data from he developed a questionnaire about the potential sales of say a product or whatever he wanted to forecast. Then each of the managers come out with something very, very conflicting. What happened to Brother Ashraf? He get fainted. Not really fainted. I mean, he has difficulties in analyzing the response because of the conflicting informations. And then using the information, what he does, and then he will reanalyze and then tune up or adjust the questionnaire, send it down again to the different branches, and then the branches answer. And then this time when they respond, it's almost close or almost consistent between each other, but he is not very satisfied. He adjusts the question again and then send it out again and make some prediction until he is very satisfied. Once he's satisfied, it appears that everybody come up with almost about the same consensus. Then he make the decision. So when it's almost reached, then he make the decision. So this one is a ding dong approach. Up, down, up, down, up, down. That's the method. Another method is expert judgment. So this is based on an expert in a particular field. So you want to sell oil, cooking oil, you have to find somebody very good in this area, in the marketing of this area. Then you can ask his opinion. What do you think if I were to introduce another brand, maybe Ironman cooking oil, for example? Then what will happen? And then he can say, oh, no problem. I think your sale will be splendid. So it is recommended when conditions of the past are not likely to hold in the future. That means certain behavioral pattern cannot hold, or data not available. Another one, just scenario writing. It's just developing a conceptual scenario for the future based on a well-defined set of assumptions. So if you are experienced in a certain area, you have certain criteria, certain sets, then make simulations, scenario writing. You just, what if scenario? What if this happened, just what will happen? What will be the sale? What if this price, this design, this, then what will be the sale? So this scenario writing. Then the last, not sure the last one. This one is purely intuitions, purely intuitive, based on experience. Based on experience, based on the ability of the human mind to process information that is difficult to quantify. So can be used in groups or committee, or you do brainstorming. What's brainstorming? Storm your brain. Brainstorming, you cannot have 100 people. You have to make it into smaller groups. Then you can make effective brainstorming. That's all. Yeah, any question? Not at all.
Doctor,
Yeah.
I'm a bit unclear about the adjustment of seasonal index.
Oh.
Which we need to make it, which we need
make
to
it into 4.
Yes, to the sum of
Okay.
the seasonal index equals to 4.
Okay, let me retrieve that. Share screen. Okay, I just put any number here. I don't backtrack. If I were to have 0.25, 0.36, 0.35, 0.25, 0.20. What does it add to? 0.9246, 0.96, right? Do you agree, brother? Yeah, I want to add this number, 0.96. Hello? Brother, are you there? So now I want to make it total 1. What do I do?
I got 1.06.
1.06. Oh, let me change this one. I want to make it. Okay, let me change this number. I want to illustrate 0.10, let's say. Do you get 996, 5? Oh yeah,
Yes,
5,
yes.
0.96. Now let's say you want to make it equal to 1. What do you do? So what you do is 25 times 1 divided by 96 is 0.25 times 1. You get a number. Then so the second one also the same, 0.36 times 1 over 0.96 equals a number. Then the third one, 0.25 times 1 over 0.96 equals something. Then the last one is 0.1 times 1 over 0.96. Then the resulting numbers, you add them together, whatever number here. I'm not calculating. When you are calculating, when you add them together, it will equal 1. That's the idea. Just now, what we want equal 4. Equal 4. Say 3.96. So whatever number up here, 0.36, let's say, times 3.96 divided by 4. Are you okay? The new number, add together, you will get, will get 4. Are you okay? Can try out this one.
Okay. Understood.
Okay.
Do we need to adjust it every time we do the seasonal index?
As I said just now, if it is out of 4, if you have 3.96, 3.97, no need, because once you change it will be very minor, say 0.36. If you change this, become maybe 3.65 only, 3.65, very insignificant. But if this is somehow this one you get 3.85, and I think it's better to regularize. Okay. All right. I think it's best to end the class. Shall we end the class? Attendance. Please put in your attendance. No, 42. 42. Okay. If there is nothing else, then we end our day with the recitation of Suratul As. Bismillahirrahmanirrahim. Wal asina inna sadana ila lazina amanu wa tawasaw bis. Thank you very much, brothers and sisters. See you next class.
Thank you so
Thank
much.
you, Doctor.
Thank you, Doctor.
Most welcome.
Thank you, Doctor.
Thank you,
Most
Doctor.
welcome. Yeah, welcome. Most welcome. Okay, I end the class now. Assalamualaikum.